Good evening, dear students. Now I want to discuss one JEE Advanced 2024 question. This question is related to aldol condensation and Kenzero reaction. Complete the reaction of acetaldehyde with excess formaldehyde. Upon heating with concentrated NaOH solution gives P and Q. Compound P does not give Tollens test, whereas Q on acidification gives positive Tollens test. Treatment of P with excess cyclohexanone in the presence of catalytic amount of para-toluene sulfonic acid gives product R. Sum of the number of methylene groups and oxygen atom in R is. So first one, acetaldehyde react with excess formaldehyde. Upon heating with concentrated NaOH solution gives P and Q. So acetaldehyde with excess formaldehyde. Now, so acetaldehyde excess formaldehyde. So this is acetaldehyde. When it react with, so acetaldehyde, this is functional group. This is functional group. So functional group adjacent carbon is alpha. There are 3 alpha hydrogens. That's why with strong base or dilute base, it can involved in aldol condensation. So first here NaOH is there. So here OH minus can terminate alpha hydrogen. Then water eliminated here. So that base can terminate alpha hydrogen. Then which is formed carboanion. C double bond OH. Carboanion. Now, why alpha hydrogen easily removed with base? Because the formed carboanion is resonancy stabilized. This is resonancy stabilized. That's why alpha hydrogen is easily terminated with base. So this is the reason. This is enolate ion. Why only alpha hydrogen easily removed with base? Reason, the formed carboanion is resonancy stabilized and form enolate anion. Enolate anion. Understood? So now you can take one of the resonancy form, that is carboanion. This carboanion react with formaldehyde. Understood? Formaldehyde. So now nucleophilic addition mechanism takes place. Then CH2 C double bond OH. Now new carbon-carbon bond formation takes place here. CH2 O minus. Understood? Now followed by protonation. Then CH2 C double bond OH. Here CH2OH. Which one is formed? CH2OH is formed. Now once time aldol addition reaction takes place. Which aldol? Crossed aldol. Acetaldehyde alpha hydrogen containing aldehyde, formaldehyde do not have. That's why among the 2 aldehydes, at least one aldehyde having alpha hydrogen that involved in crossed aldol condensation reaction. Once time aldol reaction takes place. Clear everyone? Now one more time you can react with formaldehyde, presence of base. Then this alpha hydrogen terminated. In the place of hydrogen we can write CH2OH. Now second time aldol addition. Now this is first time, this is second time aldol addition. Now you can do third time aldol addition because third alpha hydrogen is there. No, that's why third time aldol addition reaction. Formaldehyde with base. That third alpha hydrogen replaced with CH2OH group. Already we discussed mechanism. So CH2OH, now CH2OH and CH2OH. Clear? So 3 alpha hydrogens already replaced with 3 CH2OH groups. Now this is third time aldol addition reaction. Now in this molecule there is no alpha hydrogen. Is it right? There is no alpha hydrogen. That's why now if you will use formaldehyde, if you will use fourth mole formaldehyde, then what happen? In this molecule there is no alpha hydrogen. Here also there is no alpha hydrogen. That's why here Kenizero reaction takes place. Which reaction takes place? Kenizero reaction takes place. So very important, Kenizero reaction. Kenizero reaction takes place. So this is bulky aldehyde, this is simple aldehyde. In Kenizero reaction, that bulky aldehyde reduced. That bulky aldehyde reduced. CH2OH, CH2OH, CH2OH. That bulky aldehyde reduced. Now that simple aldehyde, formaldehyde oxidized to formate anion. Understood? So now bulky aldehyde reduced, simple aldehyde oxidized, because simple aldehyde involved in nucleophilic addition reaction. Then hydrate ion transfer takes place from formaldehyde to that bulky aldehyde. So bulky aldehyde reduced, simple aldehyde oxidized. Clear everyone? So now here this bulky aldehyde reduced, that reduced is called pentaerythritol. Its name pentaerythritol. Pentaerythritol, its name. And you know this is called P. Understood? And this is called Q. This formate ion is Q. Clear everyone? Understood? PQ. So now coming to here PQ. Now P does not give Tollens test. Is it right or not? P does not give Tollens test because Tollens test means which one? Aliphatic and aromatic aldehydes can be involved in Tollens test. But here any aldehyde group is there? No. So any aldehyde group is there? No. That's why it does not. it does not give Tollens test. It does not give Tollens test. Understood everyone? Now coming to Q. Q on acidification gives positive Tollens test. So now acidification. So Q acidification means H plus protonated with H plus, then you will get formic acid. So is it give Tollens test? Yes, 100%. This is exception. This formaldehyde from this side, sorry, this formic acid from left side, you can observe aldehyde group. So generally Tollens test means which will give positive Tollens test? Aldehydes, aliphatic aromatic aldehydes. But this formic acid can give positive Tollens test. Reason? Yes, in formic acid also aldehyde group is present. Aldehyde group is present. That's why it gives positive Tollens test. Positive Tollens test. Understood everyone? Yes. So 100% satisfied. Now treatment of P with excess cyclohexanone in the presence of catalytic amount of para-toluene sulfonic acid. This para-toluene sulfonic acid is acid. So presence of acid P means that pentaerythritol reacts with cyclohexanone in the presence of acid gives one product R. In that product R we have to count methylene groups and oxygen atoms. That sum is answer. Understood? So now treatment of P with the excess cyclohexanone with okay, so with excess cyclohexanone in the presence of catalytic amount of PTSA gives product R. Now, here we can write cyclohexanone. This is the cyclohexanone, excess cyclohexanone. Now, that pentaerythritol, can we write like? Yes, pentaerythritol. This is pentaerythritol and cyclohexanone and cyclohexanone. Understood? Cyclohexanone. Now, para-toluene sulfonic acid. Okay, para-toluene sulfonic acid means that is the catalytic amount of acid. Now, gives compound R. Gives compound R. Is it right? Gives compound R. What is that compound? We can write here like water eliminated here, presence of acid, here water eliminated. Then which compound is formed? Okay, this compound is formed. Which compound is formed? This compound is formed. Understood? This compound is formed. Actually, this is ketonic carbon, na? So this is ketonic carbon. This is one ketal. This is ketonic carbon. This is one ketal. Now this is R. So this is R. Understood? This is required. Final required compound R. So in this are number of methylene groups. So number of methylene groups. Number of methylene groups. And number of oxygen atoms. Number of oxygen atoms. Number of methylene groups. How many methylene groups? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 methylene groups. How many oxygen atoms? 4 oxygen atoms. How many oxygen atoms? 4 oxygen atoms. Total how many? 18. So this 18 is the right answer. Understood everyone? This 18 is the right answer. I hope everyone understood this solution. Yes, number of methylene groups plus number of oxygen atoms. 14 plus 4, 18. So this is the solution. This is the solution. This is JEE Advanced 2024 question. Clear? In this reaction, 3 times aldol addition, 1 time Kenzo reaction takes place. Then pentaerythritol is formed and formate ion. So this is the solution. I hope everyone understood this one. Thank you. Thank you so much.